Hello guys, welcome back to this channel. Today we'll continue in our preparation for WAEC for this year physics. WAEC this year is physics. And welcome back to PhysicsBible. I'm going to give you the top 10 topics for physics WAEC, both for OBJ and theory section. Even practicals, you expect some of the topics to come out from these particular ones. And you can see I begin with number 1, electricity, because even in practical, you expect one practical question from electricity. And then in section B, you are going to also expect questions from electricity. And then in OBJ, you expect 2 or 3 questions under this. And I've captured all the topics under electricity and summarized them for you. So, welcome back. If you are new, please subscribe, because I'll be bringing you in-depth analysis of this subject as we prepare adequately for this year's exams. So, top 10 topics for physics, WAEC exams, and even NECO exams. Number 1 is electricity. Electricity, yes. Under electricity, you are expected to know your circuit diagram for direct current. Your circuit diagram for direct current, and also your circuit diagram for alternating currents. Is that clear? For direct current, most of the components you are going to be seeing are resistors. You are going to see your voltmeter being connected, meaning they will ask you for voltage and they will ask you for current, meaning that what you are going to apply here will be strictly Ohm's law. Is that clear? This is your source. This is your source, all right, which is your battery. You can see there are 2 here. We call them battery, not cell. A cell is a single unit here, all right. If you see 2 of this, it means they are battery, or it is battery. Now take note of this circuit. What kind of connection is this? You can see this is series connection, but there is something I want you to pay attention to: how to identify circuits. For this particular voltmeter, normally we connect voltmeters at this point. There will be a splitting, is called, or are called current. Take note. Charges, which becomes and usually generate heat in the circuit, and then energy is being consumed by the load. Take note of all this. So you should know that Ohm's law relates voltage, current, and Ohm's law says V equals IR, where R is constant. Voltage and current varies directly proportional to each other. Exactly. As voltage is increasing, current will increase. As voltage is decreasing, current will decrease. But this resistance, it means that voltage and current, this graph here, if you look at this graph, this straight line here, the line of best fit indicate resistance, a constant value. Then this is voltage and this is current. If you are asked to plot voltage against current, or if you are asked to solve any problem, this is what you need to observe. Please take note of all this. Then energy is the work done by moving charge. So when this charges begins to move in this circuit, energy is being consumed, and as energy is present, power is the rate of doing electric work. So you can be asked to calculate for voltage, you can be asked to find current, you can be asked to find resistance, you can be asked to find energy, you can be asked to calculate for power. Please take note of all these terms. Then for energy, E equals VIT, and it is measured in joules. The same thing with work done. Exactly, the same thing with work done. Then power equals VI. Take note of that. That is current multiplied by voltage will give you power. Please take note of all this. Then I will also capture resistivity, because sometimes 1 or 2 questions can come out from resistivity. Okay, resistivity depends on the material and the temperature, the type of conductor used, and the temperature of that environment. also affect resistivity. Hence, resistivity rho equals R times A divided by L, so that our R is our resistance multiplied by area divided by length, so that our SI unit gives us ohm meter. While conductivity is the opposite of resistivity. Conductivity is the ability of material to conduct. Alright, so if you check, you see conductivity here is the inverse of resistivity. Hence, if you are asked to find conductivity, you first of all find the element which gives us reactance and in this circuit. Now, just like we have resistance here, for RLC circuit, resistance, the whole of this represent resistance. The whole of these components. I have R, I have L, I have C. All of them are related by opposition. Hence, in RLC circuit, we can measure reactance in L and C. What is L? L is inductor. Okay. C is capacitor. This is capacitor. This is inductor. This is resistor. The function capacitance. This is measured in farad. This is measured in Henry. This is measured in ohms. Take note of that. Then when you combine these three together, the resistance, the opposition offered by both resistor, inductor, and capacitor will give you impedance. This Z represents impedance, and it is the square root of R squared plus open bracket XC minus XL minus XC squared. Now, this is what it means. Take note, pay attention to this part very well. Now, for R, this R here is this. You square this R, this value here. For this L, this inductor, you don't use it directly here. Alright? Instead, you convert it to reactance. And in doing that, then we will now have XL equals 2 pi FL. This L, the value here is the L here. You come and substitute into this. Your frequency is 50 hertz. Your frequency is 50 hertz. Take note of that. And this is pi and this is 2. Once you have solved for this, it is this value here that you are going to substitute into this. Then once you are done, the next thing you do is to find XC. For XC equals 1 upon 2 pi FC. Okay, 1 upon 2 pi FC. This C here is the value of the capacitor here, and then your F is the frequency. Take note of all this symbol. Then if you look at this table here, reactance summary. I have the type, I have the inductive reactance. This is the symbol XL. This is the formula. By expansion, that was what I wrote. Is that you now have 2 pi FL. Is that one clear? Please take note of all the ohms, meaning they are taking the place of resistance. Alright? Inductive and capacitive was this. Then you can be asked to find voltage under was IR. We are now replacing R with Z. Calculate for power here. You should know that power uses mutual inductance to step up or step down voltage. We use transformers to either step down or to step up voltage. You have your number of turns in the primary and the number of turns in the secondary. You have the voltage in the primary and voltage in the secondary. You have current in the primary, current in the secondary. You have power output. This is power input. This is power output. And with this, you can find efficiency under transformer. And this is your general formula for transformer. Please take note of this. And for efficiency, you have power output over power input multiplied by 100. So take notes of these. Next, we go to motion. This is one of the topics you expect from WAEC. This topic is one of the topics that is frequent in WAEC. Now, motion is a change in position of an object in respect to time. So as object begins to change their position, what happens? Motion is done or is carried out. Now, how this? We now have the equations of motion. Before you arrive at this equation of motion, equals distance over time. This is our basic formula under motion, and this formula is the general formula that most of the physics topics rely on. Take note of this. Then equation 1 v equals u plus at. Equation 2, if you are given time, all right, if you are looking for distance, you can use equation 2 or you can use equation 3 to do that. And then we have this equation also that you can also use as the fourth equation under motion. But this one, you can also get it by the combination of any of these two. Please take note of that. These are the interpretation of each of the terms. All right, we have initial, we have final, with velocity, and then we have acceleration, we have time, we have displacement. Take note of these. Now, these equations of motion can be transformed into equations for motion due to gravity, and hence you can see what is happening. All right, let me show you something quickly. Now, I group this topic based on their relationship. Look at equation 1, v equals u plus at. Look at this, v equals u plus gt. A becomes g. Is that clear? Equation 2 now. For equation 2, we have s equals ut plus half at squared. Then under gravity, s equals ut plus half gt squared. This s can become h based on height. Is that clear? Based on this height. Hence, this s can become h. Take note of that. Then the third one here, I have v squared equals u squared plus 2as. V squared equals u squared plus 2gh. Okay, 2gh. Take note of this. And then this, you can also use this for that. Our constant value is 9.8 meters per second. Now, when you throw an object upward, your u at this level is 0. All right. Then, when you are releasing an object, the final velocity, when you are throwing an object, your u here is not 0. Exactly. While your u here, your v here is 0. When you are releasing, your u here becomes 0 and your v here is not 0. Please take note of all these differences. Now, if you observe, equation of motion SUVAT relate displacement, velocity, acceleration, and time. Motion due to gravity occurs when objects fall freely near the earth. Then you now see projectile. It moves in 2 dimensions under gravity. Now, for projectile, you are combining linear motion plus acceleration due to gravity. It means that you are combining this and this together to give you projectile. Is that clear? This is projectile motion. Now observe, this is acceleration due to gravity. This is linear motion. It is the combination of these two that gives you projectile because the object moves in this particular direction. Hence, you have your theta, you have your height, all right, maximum height, you have your range, you have the time of flight. Is that clear? Please take note of all this. So, to resolve u into components, u of x equals u cos theta. For x-axis, you use cos theta. For y-axis, you use sine theta. Take note of all this. Very important. Then u of y is u sine theta vertical. This basically interprets what I just said now. Then time of flight, which is capital letter T, is 2u sine theta over g. Take note of this formula. Very important. Then small t is u sine theta over g. All right. The maximum height, which is capital letter H, is u squared sine squared theta over 2g. All right. So, and range is r equals u squared sine 2 theta over g. Take note of all these particular formulas. Very important. Now, let me capture momentum, even though I put this in one of the topics. Momentum, we have linear momentum, P equals mv. This P represents momentum, not power. Is that clear? Then our m is mass and our v is velocity. So mass multiplied by velocity gives you momentum. Then we have laws of conservation of momentum. You have momentum for the first body, and for initial, this is another initial momentum. For second body, this is final momentum. For first body, this is final momentum for second body. Take note of all this. We are just repeating this particular formula. M mass times velocity plus mass times velocity plus mass times velocity plus mass times velocity, depending on the number of bodies. This one, it means we have two bodies, M1 and M2, and this part represent initial, this part represent final. In an isolated system, total momentum before collision equals total momentum after collision. Take note of that. Then common quantities, you should know displacement. All right, these are the dimensional formulas. Take note of all these dimensional formulas. Take note of all these SI units, because questions can come from these parts. Is that one clear? Then for projectile, we have path. The path is parabolic path. We have the horizontal motion, which is uniform. We have the vertical motion, which is uniformly accelerated as g downward. At highest point, v of y equals 0 is at 45 degrees. Take note of these constant values. Is that clear? Please take note of all these. Number 3, waves and sound. This topic is so important. Yes, very, very important. Take note of this. Waves. We have transverse wave, we have longitudinal waves. For transverse, the direction of oscillation and the direction of vibration, they are perpendicular to each other. Is that clear? Under this, you have your wavelength. All right. Under this, since you have your wavelength, from here to this point is one wavelength. Is that clear? Then you have your crest, you have your trough. All right. Then what again can we find from here? The time it takes to cover one wavelength is what we call period. All right. And frequency is the number of oscillation per second. These are some of the terms you easily find under this topic. Wavelength, distance between two successive points in the same phase. This is wavelength. Then frequency is the number of complete oscillation per second. And then time, which is period, is the time taken for one complete oscillation, and it is given as 1 divided by frequency, because frequency and period time, they are inversely proportional to each other. Then we have the amplitude, which is the maximum displacement from the equilibrium position. Is that clear? Please take note of this formula. Wave speed v is given by f lambda. Once you know this formula and you know t equals 1, you know t equals 1 over f and f equals 1 over t, you can substitute into this and obtain whatever you need to obtain. Is that one clear? So we move further. We have the longitudinal waves. All right. Under longitudinal, we have compression and rarefaction. All right. Under this, sound wave exhibit this, while transverse light waves exhibit this particular wave. So take note of this. Now, you can see I was telling you something. I said the formula for velocity equals distance over time. Is a basic formula. You can see that was what was used here and being transformed here to obtain this particular formula. Is that one clear? So once you know this particular formula, everything becomes easier for you. Then we have the summary here. Look at these formulas. Please know this particular formula. It's very important if you want to easily pass. Then we have echo under sound wave. An echo is the repetition of sound heard after reflection from a distance. Under light wave, we have reflection. Under sound wave, we have reflection. For light wave, angle of incidence equals to the angle of reflection. For sound wave, we will now have echo. All right. So we are now going to have 2D for echo. So D equals VT over 2. And this is gotten from, we know that V equals distance over time, isn't it? So since D equals distance over time, because of echo, the man's voice will move from here to hit this surface and then return. So moving here, I have X. In returning, I have X. So X plus X will give me 2X. That's why I'm having 2D here. Exactly. So here it means V equals 2X over T. Or you can say V equals 2D over T. If you make D the square formula, you obtain this particular formula. I hope you are learning from this. Take note of that. And then we now have what we call reverb. Then vibes is the same, open at both ends. Hence, they are taking the same shape. Why this is the only div we are having for here. This is between closed pipes, open pipes, and the rest. Frequency F naught. All right. Then we have first tone harmonics and then first overtone. I don't know if I'm getting this. Then we have F3, we have Fn, as many as possible. You keep on changing this general formula. This is your general formula. This is your general formula where your n equals 1, 2, 3, 4, 5, and the rest. Please take note of all this general formula. Exactly. If you know this general formula, you'll be able to generate whatever or whichever formula comes out in your exams, and you solve a problem and you move. So please take note of all this. So we are done with number 3. We go to number 4 now. I have lights and optics. Very important. Practicals, yes. Section B, yes. OBJ, yes. Under light, we have what we call reflection of light. Reflection is a bouncing back of light when it strikes a surface. All right, and we know that this is the surface here. All right, this is your surface. This is a mirror. Let's assume it is a mirror that is being coated at this end. Then this is our incident. This is our incident ray. All right, this is our incident ray, and this is our what? Reflected ray. Since we are dealing with reflection, we call it reflected, not refracted. Then this is our normal. Are you here? So please take note. And the angle of incidence equals to the angle of reflection. This angle here is equal to this angle. Is that clear? And which is why we have laws of reflection. The incident ray, reflected ray, and the normal at the point of incidence lie in the same plane. And then number 2, the angle of incidence and the angle of reflection is or are constant, and it gives us the idea of Snell's law. Now observe something quickly. Let me guide you under this. You can be asked to find the glancing angle. This is your glancing angle. Exactly. How are you going to get this? You know that the angle here is 90 degrees. So if you're able to get one of these, you can subtract from 90 to obtain the other one. I don't know if you are following. Then you can be asked to find the angle of deviation. If I complete this way, normally light travels in a straight line. Okay, if it travels here in a straight line, then if I complete this, it gives me 180. All right, so if I know my angle of incidence and my angle of reflection, I will subtract these two from 180, and because R equals I can say 2I. Exactly. I can say 2I plus the angle of deviation equals 180. All right. So take note of this particular explanation. Then I have what I call refraction of light. Refraction of light. Refraction is the bending of light when it passes from one medium to another. Light bends towards the normal when it enters a denser medium. So light bends away from the normal when it enters a rarer medium. So this is reflection and this is refraction. For refraction, the ray of light will bend and penetrate, then it comes out. Is that clear? So if this is air, this is water, this is air. All right. And then we have our Snell's law as sine I over sine R. Take note of that. Please, sine, let me write it for you. Sine what? I over sine R equals refractive index. Please take note of all these formulas. Then refractive index, I can also have C over V as refractive index, because the refractive index of a medium is the ratio of the speed of light in vacuum C to the speed of light in of the we'll call it converging lens. I'll have the concave lens. I'll have the concave diverging lens. All right. So take note of where the positions are real and virtual images. These are important things to note. While for concave, thinner at the center, thicker at the edges, opposite to these images. Look at Vela, which is 1 upon F equals 1 upon V plus 1 upon U. While your F is your focal length, your V is your image distance, and your U is your object F. If you are given R, how are you going to find F? How are you going to find F if you are given R? Is it R over 2 or R equals sorry, I'm having issues with my pen. So I'm asking you a question. If you are part of this live, I said if you are given the radius and you are not given the focal length, how can you convert this radius to give you your focal length? Drop your answers in the comments quickly. Then we have what we call magnification, which is either image distance over object distance or image height over object height. This is your formula or are your formulas for magnification. Please take note of this. Object beyond 2f, the image becomes real and inverted. It diminished between f and 2f. Please take note of all this. These questions can come out. Then object at 2f, image is real, inverted, same size as 2f. Alright, number 3, object between f and 2f, image is real, inverted, magnified, and beyond 2f. Then object at f, where's our f here? Object at f, what are you going to have? Image at infinity, no image on the screen. Take note of all this. Then object at between O and F, what are you going to have? Virtual image, upright, magnify, same size as the object. Take note of all this. Please remember all these SI units and their dimensional formula. Remember, light travels in a straight line in a homogeneous medium. Angles are measured from normal, so you must introduce your normal. Real images can be formed on screen. Virtual images cannot be formed on the screen. At a glance, please take note of all this. I equals R, and Snell's law gives us N equals sine I over sine R. Please take note of all these formulas. Very important. For today, I will stop at number 5. Tomorrow we'll continue with the rest. Number 5, fields, gravitational, electric, and magnetic. Majorly, this is under SS2 or SS3 for in some schools. Gravitational field. A gravitational field is a region around a mass within which another mass experiences a gravitational force, and which is why under this topic you now have small g and you have capital G, as you are going to see it later. For small g, it is gotten from your formula for force. or which is W is equal to mg. Take note, if you make G the soil formula, you will now have this particular formula, G equals F over M. Alright, then we now have what we call gravitational constant, and this is the value 6.67 times 10 raised to the power minus 11 Newton meter square per kilogram squared. Now you have your mass, you have your distance from the mass, you square it, you have your constant, and you have your small g. This is a formula that can help you out in solving problems under this. Then electric field. An electric field is the region around a charge within which another charge experiences an electric force. Alright, electric field strength is E, and it is force per unit positive charge. So this is your formula for electric field, where F is electric force in Newton, Q is your test charge in Coulomb, and E is electric field strength in Newton per Coulomb. So you now have this. For a point charge Q, I have E equals K, this is a constant, multiplied by Q over R squared. Alright, this is the same scenario with this. This Q is the quantity, is the matter, and this M is the body. This is the body. I don't know if I'm getting it. Then the G is your constant, your K is your constant. Take note of all these particular scenarios. Then we have magnetic field. A magnetic field is the region around a magnet or a current carrying conductor within which a magnetic pole or moving charge experiences a force. Now, magnetic flux density B is the force per unit current per unit length, and we have this particular formula. So take note that your F is magnetic force, your I is your current, your L is your length of conductor, and your B is your magnetic flux density measured in Tesla. Alright, so please take note of all these particular formulas. This is mu U naught multiplied by current divided by 2 pi r. Take note of all this. This is your permittivity of free space as U naught or mu, and then we have our current and we have our r, which is perpendicular distance from the conductor. I believe you are learning one or two things from these topics. You have to read this topic, make some revision about them. Then field lines, they emanate from positive charges from here to this. So which is why you will now check your arrowhead. Alright, your arrowhead will always be pointing to the negative terminal. Then terminate at negative charges. They never intersect. You can see they never intersect. Then field lines, they emerge from North Pole and enter the South Pole. Similar to this, north, positive, negative, south. And then they formed a closed loop and they never intersect. So comparing all this together, we should know that we have our mass for gravitational field. For electric field, we have our charge, all right, replacing each other. And then for magnetic field, we have this for electric field, this magnetic field, we have magnetic current is given in I. Then for test quantity, we have our mass, we have our charge, we have our moving charge or current. Then our field strength, attractive or repulsive, depends on the direction based on the meter squared per coulomb squared. And please take note of this diagram. If you understand this diagram, then we also have these are your constants, the key formulas you need to know. You can see that I've taken my time to create these particular documents for easy explanation. So take note of all this. From tomorrow, we go into number 6 to number 10. Do well to join us in tomorrow's live so that you don't miss out in studying and preparing adequately for your exams. So practice, memorize, apply. That is the PhysicsBible way. Welcome. If you have not subscribed, please do so and turn on the notification bell so that anytime I drop any video, you will be alerted immediately. Thanks for joining today. If you have questions, you can drop them in the comments. And I can say peace to you. I'll see you in the next one.